We present the NSNet, Non-saliency suppression sampler for efficient video recognition. Efficient video recognition is to classify videos into predefined classes using as few computes as possible. As a line of efficient video recognition methods, the temporal sampling-based method includes two stages in its typical pipeline. Firstly, we train a lightweight frame sampler to sample a small number of silent frames. For example, we use a score model to score all frames and select top case score frames. Then, we use an expensive recognizer to evoke recognition only on those sampled frames. There lies two main challenges in this task. First, non-silent frames contain complex contents, so it is difficult to discriminate the silent frames and non-silent frames. Second, with only video labels, this task lacks effective separations to train an efficient sampler. Our work is motivated by the question that how to devise effective separations. Previous methods typically take all frames as the positive samples of video category. However, this may result in falsely high score for those non-silent frames. To solve this problem, we assign different labels for the silent frames and the non-silent frames to suppress the score of non-silent frames. We propose non-saliency suppression mechanism. Here, we first define a non-silent category, which is a different category from all the semantic categories. Then, we assign labels for silent frames and non-silent frames at both frame and video levels to learn multi-granularity saliency cues. Frame scrutiness module, we firstly used the expensive recognizer to generate NSNet pseudo-frame label, a modified one-held categorical label which satisfies that for non-silent frames, there's higher value at a non-silent category and a lower value at a ground truth video category, and vice versa for the silent frames. In test, we score each frame by maximum confidence among first C categories. Video glimpse module, we attach an attention module above frame features and optimize the model by two video classification losses. The first is the classification loss between the attention aggregated feature and the ground truth category. The second is the classification loss between the aggregated feature and 1 minus attention width and the label of the non-silent category. Last, we score each frame by the attention width during testing. We fuse the saliency score of two modules to obtain final score and select top key frames as silent frames. NSNet achieves the best accuracy efficiency trade-off among the recent competitive methods on ActiveNet, ECCV'22, and mini-kinetics dataset. We present extensive ablation studies to validate the effectiveness of our NS mechanism and other designs. It can be observed that with the proposed NS mechanism, our approach can sample much more indicative silent frames. That's all. Thank you.